Good morning, everyone. I'm going to tell you right up front, I don't have any slides today. I hope you're not all bummed or something. This is supposed to be a discussion, supposed to be interactive. I assume there's going to be some questions about AFM. I've been talking about this now for probably 3 or 4 years at these things, so I do want to continue to give you an update. We've learned a lot. We've done a lot. We've failed a lot. We've succeeded a lot. That's how things go, right? It's called science. As much as we hate to admit it, we're all in scientific experiments every day, right? So I want to start the discussion by talking about some real customers, how they're using AFM today, some of the things we had to maybe overcome, some things that are working really well, right? So the first, and I'm going to use a marker, so I'm going to warn you my art is very bad, but we'll work it through, right? So I want to talk about 3 scenarios. The first one is a DR scenario using independent writer mode with an interesting twist in how we can test the DR live. The second one is a global namespace scenario, which was actually quite interesting because it was a media company in a country with very poor WAN performance, to say the least. And we had a lot of challenges there that we had to overcome, and they're actually very happy and very successful now. And the third one I want to talk about, just a kind of a more generic AFM DR scenario. Is everyone familiar with AFM DR? Okay, good. So I'll cover that in a little bit because it thinks a little differently than AFM, and I'll kind of show you how we got there with AFM DR. So the first thing I want to talk about is the IW mode DR type scenario with this cool test capability that we came up with. So I'm just going to keep it simple. We have cluster 1, right? So we have a cluster. It's a Hadoop cluster. It's FPO. It's shared nothing. They're running Hadoop analytics on it. And they wanted a DR capability, right? So this is their bread and butter. They run a lot of jobs on this. So we created a DR site. Pretty basic, right? You see this all the time. So what were the nuts and bolts? What were the things we had to do? First of all, ingest comes in knowing it's a known thing. Comes in, I think, once or twice a day. It's a known quantity. So they ingest a hunk of data. We know when it comes in, and we know what intervals it's coming in. We know when it comes in. The other thing they wanted to do is they wanted to be able to test DR at any time, right? It's kind of like a fire drill when you're in school, right? You're in the middle of gym class. They turn on the fire drill. You go out. They wanted to see that you could test DR at any time without affecting production, right? Because you don't want to take this down just to test your DR randomly, right? So those were our challenges. So the first thing was the replication. So we chose IW mode, or independent writer mode. If you're not familiar with it, it's a read-writable mode in AFM. Who here is not familiar at all with AFM? Okay, so everybody's got the basics. We created a bunch of IW mode file sets. When you write to those, it will push the data over to here, and that's how we get DR, right? Some of the challenges with independent writer mode, though, are there's no, it's continuous, right? So there's no concept of write consistency or multi-file consistency, right? So this was one of the trade-offs we had to make in this. As you put data in here, it's going to copy as quickly as it can over to here. Of course, configurable. It'll wait a certain time. It'll take a certain time, whatever bandwidth, so on. So what we did is we said, okay, well, we know these batch jobs are coming in, or these batch loads are coming in, I think, twice a day. It's a certain amount of data. They come in twice a day. So what we did is on load, when the load is complete, meaning they copy the data in, as soon as that copy is complete, they do a flush pending, which is an AFM command. And the AFM command says, flush pending is a blocking command, right? So when you issue a flush pending, it'll flush everything out of the queue. So when things come into AFM, they get queued up in memory, and then that queue is processed by the gateway node, and that's how things get flushed across. So all we did in this case to get data consistency was, after the load, we issued the flush pending. When the flush pending is complete, since the load was done first, we know now all this data has been flushed to the other side, and then they could essentially send an ACK back to the load saying, yes, we got the data. Because we got the data and we have 2 copies. That's how we managed data consistency. The rest of it's transient data. It's created as they go, and that changes all day. Great, so now we have a copy here, right? So that's worked, and they've actually been running this production for a year. And then the question was, how do we test DR, right? Okay, so you can think of a couple ways. We can cut this, and we can say, okay, we're going to stop the copy, and we're going to run a bunch of tests, but how do you protect this data over here, right? Because you don't want to mess with the DR copy, because they want to run test production jobs on the other side so they can see that it actually works. So it's going to create data, it's going to change stuff, and then how do you sync it back up? And this all got messy. And we said, well, wait a minute, let's use AFM for this. So what we do over here is you have a file system, FS1, my famous always FS1 file system, whatever it's called. What we do is we take a snapshot of it. There's some project, I forget what they name the stuff, right? But you take a snapshot of it, and then we have another file system out here called DR test or something. I forget what they call it. So what we do is we take a snapshot in this cluster. We take a snapshot of this file system. This is our failure point. So we run the snapshot while everything's doing whatever it's doing. Now we have that. It's our point in time failure. And in this other file system, we create a local update. Local update AFM cache that points to the snapshot here. Okay, so a snapshot is read-only, and it's a point-in-time copy. If half the data was there, half the data would be there. That's just how it would be, right? So you have this snapshot. We create this local update cache. So what happens is within this cluster now, this local update is an interesting behavior cache, right? So you have a read-only cache. That's pretty obvious, right? You have this cache where you can just read data. Local update is a read cache, meaning every time I go to open a file here, it's going to copy it from here into here. But you can modify the files in the local update cache. The interesting thing is that the changes are never pushed back to the source. Okay, so we're essentially creating a copy of that point in time, quote unquote, failure snapshot that we created, right, to simulate the failure. And they can run all their tests in this local update cache. This actually works pretty well. Yeah, we have to do copies. Yes, it took some extra disk space to be able to run, but they only needed enough disk space for the active data, which they could predict. So this ended up not being that big, and cost-wise, it was very cheap to just add some extra nodes in this FPO cluster to give us enough space for this. I thought this was kind of a creative solution. We've been able to do this. So some of the challenges we ran into here was getting this DR all set up. We had some NFS and, of course, WAN issues, right? Somebody said it's always the network, right? We got the WAN issues figured out. But in general, it's actually been working fairly well. And they're using this as a consolidated project space. A bunch of different departments had set up Hadoop clusters of their own and were running their own stuff. And so they decided to consolidate this. So this is going to grow, and this is going to grow. Any questions?
Is there any design consideration around the DR target? Does it need to be a different GPS cluster?
This here?
Yeah.
It just needs to be another file system.
Okay. So the AFM documentation, in I think 4.2.2, has some ambiguity around what the prerequisites are to be an AFM cache of a home. And yeah. It made it sound like it had to be a different cluster. It sounds like that's not the case.
You're absolutely right. The comment was, it sounds like these things have to be different clusters because I'm making a cache pointing to this home or target. Not at all. It's just, a lot of it was written from the concept that this is what most people do. In fact, I think when we did the POC for this, since we used NFS here, between these two, even though it was in the same cluster, this was actually the same file system. Because when you use NFS, it has no idea it's the same file system.
If you were to use GPFS natively, would it need to be a different cluster, or could it be the same?
Just has to be another file system. Okay. And I think in production, that's what they went to as a second file system. And that's a safety limitation. There's no code limitation inherent in AFM for that. If you have it in the same file system, you can get yourself into a loop scenario where you're duplicating inodes and bad things, and so we just disallow it. Right? Does this make sense? So we used two interesting features of AFM, IW mode, and then we used this local update for the DR test.
So they keep that DR test permanently?
No, well, the file system's there permanently, but once they run their testing and they're done and they say it worked, they just delete this local update cache and it goes away.
So they periodically relink it and test it again.
That's right. They create a new one. I think it's once a quarter. They check it and they just create a new one and run their tests.
Before you erase everything,
Yeah.
were there any design considerations around using independent writer like site-to-site latency or anything like that? Because I know I had a customer that would use an AFM cache out in Australia, and 200 millisecond latency between his home and his cache, and well, this was early versions of independent writer, able to corrupt data, but because of the latency between the two, it became a problem for metadata operations.
We'll talk about more in the next scenario, but here that wasn't that much of an issue, and the reason it wasn't is because your load was once a day, and that's in a I'll call it /data, and there's a /scratch. I think they call it local or something. This is where all the operational work does. This is pretty much read-only.
Okay.
And we designed it that way so we didn't have any of those issues.
Okay.
And this isn't a bad way, and it's within the same city kind of thing. It's not too bad.
It's not from the United States to Australia.
Yeah. From Queensland to California, right? So, exactly. We didn't have that here. We intentionally designed to run all that stuff here to get that out of the way. Any other questions about this scenario? Okay. So that was what we found. I'm sure I've mentioned this probably 20 times, right? When we first made this, it was for distributed caching, and we quickly learned that that's interesting, but that the most value comes from a DR-like scenario. And so we've implemented this DR-like scenario, and we'll evolve up to async DR here in a minute. But that was one of the first ones, first models we did. The second one we did was more of what we call global namespace. Global namespace and DR kind of mixed together. So this next one's a media company, and they have 3 cities in South America. The latency between is 30 to 100 milliseconds, give or take, time of day, all that kind of stuff between each one of these sites, right? So you've got link here, and so on. They can all talk to everybody. So we had a couple challenges here. So there was 2 basic workloads. One is you have data that has to be copied everywhere because it has to be reliable. Today's news, think of it, right? So if you have pictures from the president doing something today, all 3 cities may need that same picture and they want it today. They can't lose it, right? Because they need it for tonight's news. It has to be available for broadcast. But you also have another set of data of the president pictures for the last 20 years. You may never need them. They're just an archive. They're just hanging out there, but you want them when you need them. You know, if some celebrity dies or something, you want to go get those pictures today so you can go grab that information. So we had 2 distinct workloads, but they wanted to work in one namespace. They wanted to be able to get to everything from the same place everywhere. The way they used to do it was that I would, call up somebody in another city and say, hey, did you do those pictures of the prime minister? Do you have those? And they'd say yes, and they'd email them to you, and then I'd get it, and then someone else would ask for it and stuff. It was really difficult, right? So what we did is we created a global namespace, and so we essentially had a production file system, and then a bunch, I think there's 80 different archive file sets. So a couple challenges here. First of all, AFM is a one-to-one relationship, right? If you create a file at one place, let's say this is the main production site, and in AFM terminology, this is, that's the cache. So this is the cache for production. Now production has to be copied to all 3 sites. Now there's 2 ways you could do it, right? You could push the data from here to here to here, cascading them. That would work, except you have a couple issues. One, this has to go through there to get to here. So if this site's down, this guy doesn't get a copy, right? The second thing is there's performance issues when you're flushing a cache with a lot of small files to another cache that's going to another home. So it's like, all right, so how do we handle this? What we ended up doing was saying, all right, what I really need for this is a DR, and then I need access from the third site. So we created a target over here. So this production, this is the main site where production lives. Everything is copied here. Now, any of these sites can update production. Okay, this is going to get fun in just a second, right? So, well, actually, let me start from the beginning. So first of all, production points to here. So now we have a production DR copy. Excellent, right? So now we've got the data at 2 sites all the time that's continuously pushed from one site to the other. Okay, how do we get it here? This can only push to one place at a time. So what we did is we created a cache here that points this way, uses this as the home. And what we said was, okay, they're going to have their local production data, and as they do the local production, it's going to push it to here, which is good. We want it there, and then it's going to push it to there. But this needs to get data the other way on a regular basis. So what we did is we set up prefetching to say every 15 minutes, run a policy here, tell me what's new. I mean, this isn't that big. This is millions of files. It's not hundreds of millions of files, right? And the size of this is limited. It's 20, 50 terabytes. It's not a huge amount of data. And so we were running every 15 minutes a policy here. I put the list in an AFM file set, which these see, and then these prefetch based on, hey, there's work for me to do. So it's basically cron jobs running here, prefetching every 15 minutes, right? Actually, it does it every minute just to see if something's going on. So we're distributing the data out. Now we have DR copy, and then we have this getting updated regularly for this production data that has to be in all 3 sites. So if one of these sites goes down, it's no problem. They've got 2 other copies of it, and they can run tonight's news.
So did you do that because all 3 sites need to be able to contribute to prod, or did you do that because you could have done read-only AFM, for example?
That's right. You're absolutely right. Good point. Yes, I missed that. All 3 of these have directories, independent directories within prod. That's the one challenge with independent writer mode, right? Is that you and I, if we're writing in the same directory, we can mess each other up because whoever syncs last wins, right? So there was essentially a directory for each city name in there, and I only update my city, but you're right, I had my directory, and it's pushing back to here, the other way, and so on. Okay, so we had production copied in all 3 sites because everyone's updating data, everyone needs everyone else's data, and it's real time, it has to be there. But what we did because we had this challenge, right? High latency, low performance networks, we kept it small. We kept it to the minimum amount of like a month's worth of work they needed. And these are just pictures, like you're on the news, you get the picture next to you, it's just that kind of stuff. So it's not huge. And they clean this manually. Anytime they're done here, it goes into archive. So then what we did with archive is we put archive disk essentially at 2 sites. And that's just because that's where they had a bunch of content. So we picked 2 of the cities that already had a bunch of content. These 2 own the content. And then every other place just has we made them independent writers so people can update the content, but they're independent writer to the other 2 sites, and it's just on demand. So on demand, they go in, oh, I need this picture of this celebrity from 5 years ago at this event. They go in there, they grab it, and everybody can get to it directly, gets a copy locally. Once they're done with that production that night, what we did is we set up a policy in each site that says anything that's in an archive file set, cache file set, that hasn't been touched in a week, we evict it. Remember, evict doesn't mean delete. It just means we kick it out of that cache so it's not taking space at the other sites. So the challenges we ran into here was this, right? 300 milliseconds. You talked about this, doing LSs and doing that kind of stuff. A couple features we added to address this. Now this is all NFS, right? Which actually works really well in here. So one of the things we did was when you're in here and you're doing an LS, it was really slow, right? Because it had to revalidate to the other side to get the latest data. We took advantage of readdir plus in NFS. So instead of, the one test we did was like 4,000 files in the directory. I think it was, I looked for their largest directory and used that as my test. And it was taking like 2.5 minutes to do an LS. After we implemented the new code, it took less than 10 seconds and it was consistent. So you can live with 10 seconds, right? You know it's coming over a WAN. So when you update, it can take up to 10 seconds, and that was with 4,000 or 5,000 things in there. With less, obviously, it's a lot faster. So we solved that problem with this new Reader Plus implementation. The second challenge we ran into is a media company. All of these sites are serving out with SMB. So all of the access to this data is SMB. So I'll summarize it by saying we worked out some issues between AFM, high latency, and SMB. So those were the things we had to work out, right? But now this is in production. They're very happy with it, and they're looking to expand this quite significantly. This was a pilot project on a small, the nightly news.
So since it's a media company and all those Mac clients over Samba are accessing, do you run into issues with, for example, we do a bunch of stuff in media, and historically we've used other shared file systems that are orchestrated around media and SANs.
Sure.
Specifically, we've tried to use GPFS over Samba and run into problems with asset managers, data asset managers around directory change notifications and other things that Macs and these content managers depend on in order for their workflows to work. I know Protocol Node doesn't use some parts of CERNet Samba that has been developed for those additives, the little Mac plugins. Did you run into any problems with that in this customer?
We didn't. It never came up as an issue, so I just have to say it was not a non-requirement in this case. They were using Windows and Mac workstations for their media work, right? And that was, they never brought it up as an issue, so I don't know.
Yeah, I mean, I can name probably 5 different data asset managers that depend on directory change notification
Yes.
being there. Question completely aside from AFM, just because you brought it up.
Yeah, that's fine.
Is there plans for you guys to adopt the newer version of CERNet Samba that has those changes?
It's not the Samba limitation that's the limitation. It's the GPFS code itself doesn't have a notification mechanism until lightweight events. So that would be practical in this case. So theoretically, and there's no plans for this, no design, but in theory you could use lightweight events to feed directory change notification.
So if you needed cross-protocol support, yes. You can do that all within Samba using CGDB. Change notifications, yeah, you can, that code can insert in something.
Right, but it requires the file system to know that something's changed.
No, not really. Protocol Node can use CGDB to make sure that, like watch folders, for example, if somebody makes a modification in a directory that another...
Only if the modification comes through that protocol node through SMB, right?
No.
Okay,
You can use
all right.
CGDB as a backend to maintain that who's in what consistency, and there's a modern version of CERNet Samba that has those. I can't remember what the extension is, but it's like an OSX extension or .Mac. I'd have to look at it. We implemented it in a protocol stack we used to call Media Scaler, and not to go into a nightmare aside, but trying to support that and protocol node is 2 parallel tracks is no fun.
No, I understand.
So it'd be very advantageous to us if protocol node had those.
Okay. It sounds like we need a deeper side discussion on this.
Sure.
So, I'll go back to, it wasn't an issue here. So, any questions about this?
I think a lot of media companies use LTFS for storing things. Is this all on disk? Or?
They do, and there are other projects we're doing with this customer that would involve LTFS. But this project was simply, everything you see here was the project. It was very small. I mean, from this room's perspective, this was teeny, right? We're talking 10, 20 terabytes of data.
Okay.
Yeah.
So I'm curious, it seems like something like an object store would be a good fit for this. Did they consider using object storage for the
Yes, the comment was an object store would be a good fit. Well, maybe not, because all the Windows nodes and stuff want to see a directory tree, right? And so you could use an object store, or you'd use it with a gateway. And then you'd have 2 layers of stuff. That's the biggest challenge today, right? Is access to the data. Okay. Okay. So this is another, this took a while. The big things we had to work on was the NFS things, and we made a lot of improvements in the code to fix that, and then the SMB integration. But I think we've got that all hammered out now. So, and this has been in production now for, I don't remember the exact months, more than 6 months, I'll say that.
Using CES for that?
Yes. Yeah, this is using the protocol stack with CES. Okay, so we talked about using independent writer mode for DR with the ability to test DR. Talked about global namespace with some DR built in, right? So the real goal in that one was global namespace, and then they said, oh, by the way, we really would like copies of it in case one of the sites fails. So we integrated some DR into that, which you see both of them involve DR, right? Just about every instance we do, people say, ooh, I can get a copy somewhere else, and I can do it at a file level basis. So a couple years ago, we decided, hey, we really need to implement a real AFM DR solution based on AFM tools. So what we call it AFM DR or async DR. I think it refers to it both ways in the documentation. And what it is it's taking AFM functionality we have today. In fact, it's using single writer mode internally, modified certainly. And it gives you a couple features that we were kind of missing. Remember with that independent writer mode thing, I said that we had to use the flush pending to know when things were flushed. We do this with other customers that are doing continuous, and what we'll do to monitor RPO, or how quickly is my stuff flushing, is I just have a flush pending script that kicks up every 15 minutes, and it times how long it takes to complete. And the idea being that it gets in the line with the queue. When it flushes down and it completes, then I know that, okay, everything seems to be getting flushed less than 15 minutes. I'm happy, or less than an hour, whatever my RPO is. Async DR implements that at a more complete level and gives you some tools. So a couple things. We introduced some new terminology. There's primary and secondary now. We had a cache and a home before, or a cache and a target. We now have a primary, secondary, and they actually have knowledge of each other. One of the cool things about AFM, but one of the challenges with AFM too, is that the cache knows what's going on. The home doesn't even know it's a cache, or it doesn't even know it's participating. All it sees is read and write requests over NFS or NSD, right? It doesn't even know. And one of the problems with that is, for example, one of the DR things we wanted was, for your secondary, we want it to be read-only, right? Well, you can't do that if the home or the target doesn't know anything about what's going on here, right? So we added some knowledge in here to say, okay, you create a primary, you create a secondary, this gets a big, long ID, right? And you say, okay, I create this, associates with this, you pair them up. Now they have knowledge of each other. Now it's a very cursory knowledge, right? But there is knowledge of each other. And they can check some basic things. So if this guy fails, this guy becomes the temporary primary, right? You fail over to secondary. When this guy comes back up, he'll look over here, and as long as he can contact this, he'll say, oh, well, he's a temporary primary. I need to go through my failback routine, right? But things are still done independently, and I'll walk through a failover failback scenario to kind of, as a way to outline this stuff. So you have a primary file set. You create this file set as primary, that's the type. You create this, and you get a primary ID. And then you create and you don't link it. If you're familiar with file sets, you create it, and then you link it in the file system. And when it's linked in, now you see it, and it's a directory. So you create it, and you don't link it. You just create it. You go to the secondary. You set everything up on the secondary. So you create your secondary, a file set. Has to be a file set, independent file set. You associate it with this primary ID, and then you link it in, and then you typically NFS export it, but you can also do it with NSD. Doesn't matter. So once you've got that all set up, then you come back in and link in the primary. Now they're working. Now this is read-only, and it's copying everything over there, just like independent writer mode, right? Couple things we added here. One was an RPO. So every, I think by default it's 15 minutes, it's going to create a snapshot, and it uses what's called a peer snapshot, or psnap. So what happens is the snapshot that's taken here at that RPO interval gets flushed over here, and a snapshot gets created here as well. So now you have snapshots on two sides that can give you some amount of multi-file consistency. Now be careful with that, because you're not quiescing and stuff over here, so you don't have true multi-file consistency, but at least we know at this point in time we took a snapshot, we flushed whatever was out there, and we're giving you that image on the other side. So now you have snapshots on both sides, and that's what AsyncDR uses to make sure things are in sync. It uses these snapshots as references. For example, when this gets created, it creates what it calls psnap 0, which is I'm starting out, this is my day one, I have this snap 0. It uses that as its 0 reference. If it doesn't have that, it's unhappy, right? So it has to use that. So the way this works, you're running along, and primary fails, right? Okay, so when primary fails, the system administrator has to come over here and manually say, okay, you are now the primary. There's a convert to primary command. It's online, happens quickly, you say convert to primary. This becomes read-write. And for those of you that may know the details, yes, I'm skipping some detailed steps, but we're going through the high level here, right? So you convert this, it becomes read-write, and you continue on. Sometime later, assumably this comes back up. Now this is happy again. You need to fail back. There's a couple steps to fail back here. Remember, because these are loosely correlated. Now the GUI will shortly have a command that will do this for you when the GUI can talk, but the GUI's got to be able to talk to two clusters generally, which it doesn't like to do. So we have to work out some of that. So to fail back, what you have the secondary is now the acting primary, and this guy. So what you do is you say, okay, so I'm going to fail back, and time point 1 is a start. And this puts this back into failback mode. What that means is, I think it becomes read-only, if I remember correctly. The only thing that can write to it is the gateway, right? So you're not modifying this on this side. And then you do what's called apply updates. So, okay, so you start it, and it puts it in the mode, this is okay, I'm ready to receive my updates. You say apply updates. Now it's going to go over here, compare snapshots, say, hey, this is the last snapshot I had, this is the last snapshot you have in common, and then it applies a differential between those two. That's how it knows only update what I don't have. And it knows it from the last snap that they have in common. If this was an hour difference, big deal. If it's a week difference, it's obviously going to be bigger, and so on and so forth, right? Generally what you do is you run apply updates, and let's say it's been a week or something that this has been down. It's going to take a while to apply those updates. While that update is applying is going, you can still be running production workload over here. So what it'll do when it does this is it'll get a list, and it'll start applying it, but things could be going on over there, right? So the intention, our intention was, okay, maybe that takes 2 hours to do, or 3 hours to do that initial apply updates. You don't want to take your production down for 3 hours to do the initial apply updates. So you can run this. You can run this again. So the intention is you run apply updates, let it go for 3 hours, 3 days, whatever it takes. And then your downtime to fail back is, okay, I've run this maybe 2 or 3 times, but I'll just say you ran it once, you got everything over. What you do is you then stop your production over here. So you stop your production over here, and then you run apply updates one more time while that's down. When this completes, then you run a stop, which means it's stopping failback mode, meaning you're ready to start running again. So this is your downtime. This last apply updates, the stop, which is instantaneous, right? And then you can start your production workload over here. So there is a manual failover and a manual failback, and this time just depends on how active that is. Okay.
So-
That makes sense.
So I have a customer, we have a customer.
Yeah.
That wants to leverage something like this, but have a single mount point and have their applications transparently leverage whoever's primary.
Yeah. So I think for everybody else, what you're pointing out is this is a file set, right? And so you're going to have a file set and then primary 1, primary 2, primary 3, how many ever you have, right? There is a line item, an RFE, however you want to word it, to make the whole file system synchronous or replicatable, I guess, if that's a word. Not yet.
Okay. Like auto mount or whatever else to kind of mask that to the application. Like I think that's what we're doing today is just using auto mount, not GPFS mount point, but referencing it and
Links or something?
Hmm?
Links or something?
No, auto mount has the capability of you just preferring something, and if it does not respond properly, you use something else. Anyways,
Okay.
I can.
So generally what people do is they just link it, right?
Right.
So they link it back to a top level directory that they had for years that it's just where it is. But yeah, right now it's this.
And auto mount could be doing just that, using settings
Using Symlink?
or something.
Certainly, yeah. Yeah. Well, we can talk more about that because I'm not sure how Automount solves it, so maybe I'm missing something. Okay, anyway, so yes, you have to do it per file set. So you're always going to have a file system name and then a file set name, and then you can have a bunch of them or just one. Some customers just go with one and that's their path, right? It's annoying because they want just one slash, but it's making
So this same customer that wants that single mount point, they have 18 petabytes of existing data, and they want to implement ADR. And now I asked them, did you create your files in independent file sets? And they tell me no.
Yeah.
Do you have kind of a narration of how best to get them to that point of being able to use ADR
One you're going to like?
without copying all of their data or impacting production for
Right.
an extended period of time?
No. No, there's no magic here, right? So today you would create a primary and then maybe put a project in it and then put the next project in it, and that's what some people have done, right? Yeah, there's no magic.
Is it possible or supportable to make an AFM, make the new independent file set an AFM cache to the former directory
Yes.
over NFS, and then have that cache still work as part of ADR?
Yes.
Okay.
So the steps, high-level steps would be, I usually use IW mode for migrations. That's just me. So that isn't the use case I didn't talk about. I focus on DR here. But so what he's referring to for everybody else in the room is I have a directory or a whole bunch of data in my file system. You're telling me I got to create these independent file sets to move this stuff. So how would I get my structure from no file sets to file sets with the least impact on production, right? So step one, create IW, typically IW file sets. You can argue, and I call it a religious argument, whether you use local update or IW. I like IW. As long as you have push bandwidth, you're okay. Create the IW file set, prefetch, and then you break the relationship. And then you can create DR. I know my writing is terrible. These are notes to myself. So the first thing you do is you create independent mode file set in an empty directory. You point it to the you would typically break up. Generally, people have projects or months or some kind of structure. Hopefully, you can break it up into more than one independent file set, especially at 18 petabytes. Then what you would do is you do a series of prefetching. You run a policy on the existing directory. You feed that into AFM CTL prefetch. I would prefetch metadata first and then data. And kind of like the apply updates, you run that as many times as you think you want before you cut production over. And there's really two modes in that. If you have 100 terabytes of data and 10 terabytes is active on any day, you can just do a metadata update and move this stuff over, and it'll probably just fetch itself and be fine. If you have that 100 terabytes of data and 100 terabytes is changed and used every day, then you want to fetch the data and everything before you cut over, because there's going to be a lot less AFM work to do. You do the prefetching, you break the relationship. Now, in this case, when you're done with the migration, now this is my big warning, when you are completely done with your migration, you know everything's there and everything's happy, you then disable IW mode. And the reason why I say it's a big warning is you can't re-enable IW mode. Once you disable it, you're done. But you can create a primary. So you would disable IW mode. Now you have an independent file set full of the data that you want there, hopefully. Now you can create a primary, point it off to a secondary, and then you have two ways to populate the secondary. Either you can rsync the stuff over some other way, and when you hook them up, you say, you're mostly in sync, everything should be fine, and it does some checks, but it assumes everything's the same on both sides, or it pushes everything to the secondary. Does that answer your question?
It does.
Okay. So yeah, we've actually done quite a few migrations with AFM, and I'll go into that for a second. We got a few minutes. The challenge, we've been very successful. It's run really well. We've done the breaks. It's worked. The one problem we ran into is somebody, and we run into this a lot moving from other platforms. And I'll pick on IBM, right? We moved from JFS 2 years ago to GPFS. So we move 100 file systems into one file system, right? And now we're running into the same thing. This customer has like 6,000 exports they're putting in one file system. Well, that means they want 6,000 independent file sets. Of course, we don't support. We support 1,000 per file system. So 6 file systems, right? But so that's, I think, the biggest problem we've run into recently is just the number of independent file sets because you're doing consolidation. But otherwise, performance-wise and everything seems to be working. Any other questions?
That was the problem that we had when we used AFM to migrate. The independent file sets was the killer. We had a file set for each user and had hundreds of users. And we ended up going back with rsync from the DR that we created. Everything broke. We had to FSCK. We were losing inodes all over the place. Things totally broke. And so we just started fresh. The new split metadata and data block size, all these fancy things that we didn't have at 3.3 when we started.
Right, yeah.
So it was a good thing in a way, but then we sucked it all back into a single file system with lots of dependent file sets rather than independent file sets. We're not using AFM anymore.
Right, yeah.
We just tried to use it for that migration.
Yeah, you did it really early on. You're
Very
from
early.
Brown, right? Yeah.
Yes.
Yeah, I remember that. Yeah. So, yeah, we ran into some issues there.
At this point, we're in tremendous need of a good DR system that we could maybe switch to if things broke, and we're still talking about using AFM to do that.
Yeah.
So when it comes time to design that, we're probably going to talk to whoever's the expert and you or whatever,
Sure.
and say, how do we plan this so it'll work the first time?
Yep. Yeah. So yeah, you came in really early on, and I admit we had a lot of issues. This was a whole new technology, right? Yeah. And we ran into a lot of funky things because it was the first technology to do file level synchronization, the sync between two sites, and in fact.
And then the understanding that this prefetch, okay, having some specific instructions. This is how you do the prefetch, versus trying to read the doc and I think this is how to do the prefetch. We'll do the prefetch here, and then we'll run rsync over here. And yeah. How do I know if the prefetch worked? A node crashed while it was happening.
Right.
It was fun.
Yeah, we've cleaned a lot of that up. So one of the problems we had when we were doing it on your system was things like, hey, I'll just lay it out. The prefetch was the input files were not consistent. It wasn't looking at them right, and so you'd get bogus errors that really weren't errors, but you didn't know they were errors. And we've hopefully cleaned that up now. It's a lot cleaner.
GPFS would crash while it was happening, and we bring it back up, and we wouldn't know, where did it restart it?
Right. So now the way that we handle that, and we've like I said, we've phenomenally cleaned that up since I apologize, but since you taught us much.
3.5 days.
Yeah. So so one of the things we do now is we still don't make prefetch jobs persistent. So if the gateway fails when a prefetch job is in process, you start it over. But a prefetch job is so much faster these days and more reliable that even if that happens, you just start it over. And if you think about it, in general, it's not that bad to restart a prefetch, because if all it has to do is send an RPC, if it's already there, then it's not going to move any data, right? So you have to do a little catch up, right? You always have to do that little bit of RPC work, but then the data movement just goes on from what you haven't done yet. And we've actually had, I'm starting to get more comfortable. It's solid now. It seems to be working consistently. I'm always cautiously optimistic. So
one thing we're thinking about using AFM for, since we're going to have a sister site in reality, is we need to migrate to 4K block drives.
Yep.
And basically we use AFM to move stuff over to a new set of arrays, and then just break the old one off.
Yeah, so you want to move to a new block size?
Yeah.
Yeah. Yeah, and we've done that. Like a lot of people have bought ESS, for example, and they're moving from other stores to the new ESS. We use it for that as well, because they want new file system formats and things, so you can't use ILM for it. Yep.
Yeah, so that's a known understood area.
Yeah. And we generally, if it's in a data center or within a cluster even, we just use NSD protocol. It's faster.
Okay, so you can do that. You don't have to use the NFS protocol.
That's right. And so the way the NSD works is, so with NFS, the gateway will automatically, it has a NFS client built in, and it'll create the mount and remove the mount and so on. When you're using NSD, it's just, well, if it's in the same cluster, it doesn't matter, it's just a path. But if it's a multi-cluster, then you cross-cluster mount it. The gateway just needs to see the path.
Okay.
So.
Is that the recommended way of doing block migration, or are there other options?
It's becoming the recommended way to do migrations. I mean, there's always rsync and other non-GPFS tools, but there's no other GPFS tools. Yeah.
You know, we used to talk a little bit about also being able to migrate off of other arrays like a NetApp via NFS v3. Are you familiar if we executed any of those? Or?
Yeah, we're doing that right now. In fact, the customer I talked about, the issue they were having is that we're coming from thousands of NFS exports off of, I'll call them other products, into one GPFS file system. So yes, we've been in there quite a bit. And in fact, our first production customer with AFM years ago was using NFS backend and then drawing it into GPFS for analytics. That was our first production customer. So. Yeah.
Yeah, I basically have a tiered file system right now with it's very large kind of view-only file set. So but a lot of data is hot, and so we basically try to get all new data gets written into this tier. It's just automatically with the data placement policy will end up going into the slower disk pool whenever capacity gets hit. When the SD pool basically gets full.
Yeah.
Then we basically run these island policy migrations to rebalance the what data is in the SSD pool based on the file need. But given the size of this file system and the amount of data we have, it's a multi-day, and it doesn't actually complete because of just how many files and how many data.
The policies, you mean?
Yeah, the policy. So really, what is needed is an AFM cache, which basically write into the SSD pool, and then anytime data gets read, it would be fetched from the slower file system into there. But we only have one file set. Is there any improvement in performance in terms of pulling data? I know we can, if the file is large enough, you'll break up the prefetching operation across many gateways, but still it's only one file set. So has there been any improvement on performance? The gateway performance of pulling data from the primary large slower file system into the AFM cache without having lots and lots of files.
So I'll put it this way: we can fill the performance of one node pretty easily these days. I'm just going to be straightforward with you. The parallel stuff, we'd have to. I've seen it work, but I would want to make sure it would work for you as you want to use it today.
Okay.
So we can certainly fill the throughput of one node. So if that's good enough for you, great. But I'm sure it isn't in your case. So the things I would look at, because I know a little bit about your environment, it would be some of the new ILM stuff and let's say in the future, if we have like lightweight event-based migration, Island would probably be a better option based on the size and your cluster's pretty high performance. We want to make sure we keep it that way, right?
Yeah, it has to be.
Exactly.
So a lot of customers look at DR and business continuity, and they say, this is a business need that I have. And in almost the same paragraph, they use the word backup, which it really is not.
Right.
Do you kind of have a common way of backing up a business continuous environment that works with ADR?
I'm looking around for Jason because he's our Spectrum Protect guy. He's not here. So, no, I mean, there's nothing magic in Spectrum Scale that does that, right? So it would be whatever backup tool you're using. So you can use a backup tool on either side with async DR. Yes, you can back up either side. So you can back the DR side or the primary, and then you know the backup tools, you know what you have there, right? There's no other magic.
Okay. Yeah, I mean, customers want this amazing unicorn system that does it all. And we all kind of believe that primary is eventually going to go down and we're going to have to go to DR. But then to have some continuity between DR and whatever backup system is in place, you know, that is one of the asks that customers.
What do you mean by continuity between the DR and the backup system?
Right. So you could put Spectrum Protect on the primary side, right, and back it up. But when you fail over to DR, no longer are you hooked into that backup system because it only applied in primary. So having some way to also have Spectrum Protect move its source over to DR, like that's kind of.
Yeah, so what's running through my head right now is I'm a little fuzzy on the Spectrum Protect. So for example, with Spectrum Archive, LTFS, you can have two clusters, two tape libraries, right? And these are copies of each, and these are two GPFS clusters, and usually we use sync replication between them, right? This is, I wouldn't say common, but we have a bunch of these out there, right? And so you get two it's not a backup, right? I give you that, right? But it's at least two copies of the data. This whole site goes down, you still have LTFS access to this. This is available today. I would ask the Spectrum Protect guy, I believe they can do this, but I don't want to go out on a limb and say they can. Yes?
It's a slight variant, but we have one customer that utilizes GSM with 7.2 and has deployed inline vdo, and then we put an elastic storage server for high throughput for backup and restore behind that.
Well,
then you'll replicate to another TSM server with another ESS behind it. And so you do get a backup. You just have to recover from the second site for pulling the data off because of the speed of the disk on an ESS or high-end disk speed. Then they can restore at the site. Just another idea.
So So I assumed it was there, but I didn't want to make the assumption. And generally with Spectrum Protect, as long as the path is the same, it's used as the same file system.
Okay.
So if you had a DR, even if this was async, you have the DR copy over here, it's going to assume that's the same thing, and it has a copy of the tapes at the other side, or can have. Yeah, backups, DR, it's, well, you know, it's, everyone thinks that tape backups are not doable anymore, and so who needs backup? Snapshots and DR will solve all your problems.
Right, and then a malicious user goes in and you know, malwares up all of one copy of your data, and that gets propagated to your DR site, and so now it's not DR, it's just propagated malware.
It DR'd it.
It did. It made sure that those deltas were changed.
Yeah. Yeah. I think everyone here understands there's different levels of protection and different levels of what people consider backup and things. And when you have 100 petabytes, no, you're not going to be able to do a nightly on that, right?
I should also say, though, that the power of some of the offerings on Spectrum Protect is with the inline vdo. You know, we had a customer who was looking to buy a data domain that had a 1 petabyte effective, 4-to-1 ratio, 250. We drop in an ESS at 1 petabyte, it gets 4-to-1, so now you've got a 4 petabyte effective, for much less price than equal.
Yeah, so there's, yep. Cool. Any other questions?
What's next, Scott?
All right, sure.